So this question just asks us to state how many zeros there are. We don't actually have to go find them. One thing that will help us is the fundamental theorem of algebra, which says that the highest power of a polynomial tells you all the different possible unique zeros. So there's at most two different types of zeros. So this is out. There we go. Made it a little easier. Are they complex or real? So one thing you could do is you could graph this thing, and if you graph it and if it crosses the x-axis at two places, these are real zeros. Complex zeros, meaning I think specifically this should say imaginary zeros. Imaginary zeros are zeros that you don't see them cross the x-axis. If you were to make a sketch of a graph and it was x squared plus 7x plus 4 or something like that, and if the graph looked like this, never crosses the x-axis. So you know that two have to be imaginary. But if you graph it and it crosses here, the two zeros that we know have to exist are real because we can see them on the graph. Okay, so we should make a quick sketch. It'd be easiest if we could factor it, but you can't find two numbers that multiply by 3 but add to be multiplied to be 8 but add to be 5, right? 4 times 2 doesn't work. 8 times 1, nothing there. So it's not factorable. So we could make a quick sketch if we don't have a graphing calculator available to us. You could complete the square too, that's another option, but if you plug in 0, you get out 8. If you plug in -1, so that's 1 minus 5 makes -4, so that's 4. If you plug in -2, -2 squared is 4. 4 minus 10 is -6. -6 plus 8 is 2. If I plug in -3 for x, I'm trying to see if I'm going to cross that 0. That gives me 9. So that's 9 minus 15 plus 8. I can't do that in my head. That's 2. Looks like we're going up now. Oh, the vertex. That would be a better idea. So I got some dots, 0 on the x, 8 on the y, -1 on the x, 4 on the y, -2 on the x, 2 on the y, -3 on the x, 2 on the y. So it looks like it's going to make this curve, but what I should have done in the first place, the quickest way to graph a quadratic, to make a sketch, is to find the vertex with this quick little formula. -b over 2a. Okay? And b is just this coefficient, the second coefficient if it's descending powers, and a is 1. So for this, it'd be -5 over 2a. So the vertex occurs at -2.5. So if I plug in -2.5 into the function, that will tell me how low I can possibly go. And so -2.5 squared is going to be positive 6.25. And this is a negative term in the center. So I plugged in -2.5, I got 1.75, so that's as low as I can go for this graph. So basically all that work was just to give us an idea of what this graph looks like. This graph does not cross the x-axis. There are no real zeros. So there are two complex zeros, none of them are real.